Okay, let me explain one last problem in this section. We're going to revolve about a different line. And so to do that, what you need to do is just make sure, again, that you draw out a really nice picture and that you understand exactly what each of the shells looks like. If you try to follow a formula, I think you can just get messed up. So what we want to do in this problem is we want to take I'll move this a little bit like this here for you. We want to take an area that's bounded by the y-axis, positive y-axis, the positive x-axis, so looking in quadrant 1, and then these two lines, the horizontal line y equals 1, and then this line coming up here that's y is equal to the square root of x, like this. Okay, but instead of rotating around the x-axis, like the y-axis or the x-axis like we normally would, we're going to rotate it around another line, and this time we're going to rotate it around this line y is equal to negative 1/2. So we're going to spin around this line, not one of the axes. Okay, so it's going to look something like this. Okay, pretty cool, huh? Okay, so this is what we're going to spin around. So we're starting here, but we're rotating around. Now let's go ahead and let's draw a picture of what that's going to look like. So every problem do this, okay? So you draw out your axis system. Okay. Then we've got the line that we're going to rotate around. I'll put that here in blue. That was bothering me. And this is at x is equal to negative 1/2. Okay. Then we've got this other object over here that has a height value of 1 and comes up with this other function here. Okay, it looks like this. And this is the guy that we're going to rotate around. Now this guy has the equation y is equal to 1, and this guy has the equation y is equal to the square root of x, like that. Now again, it's going to revolve around. Okay, so this, I'm going to reflect it over here. It's not a great reflection, okay, but it's going to get this general look to it, right? And it's going to come back around the front. Okay, so that's what we've got. We've got this nice hole in the middle. So what we need to do is we need to take an arbitrary section of this. So I'm gonna grab a cross piece of it, just this little piece right here. And now remember, that is going to, and I'm not going to draw this well here because I'm not good at it, but that is going to create a shell, right? Because we have this shell in here. So let me go ahead and draw our shell out over here. So we have this cylindrical shell, and it looks something like this. And again, we're going to sketch this guy out flat. So we're going to take him and we're going to uncurl him. Looks like something like this, right? A nice rectangle. And it's really, really close to being a rectangle, that once this delta x becomes significantly small, it actually is it is a rectangle here. Okay, so what we need to know now is we need to know the height of the shell. We need to know this little length across, which is this guy right here, and we also need to know this big base length. Okay, well, the little guy coming across here, that's this little guy right here from the picture, right? Don't know if you can kind of see if I dot it in. Okay, if I dot in, we've got a little cross section of it, and that is this little piece, and that is what we call delta x. It's a little change in x. Okay, there it is. Now this big base length is this whole guy unwrapped, and if we like cut it right here and then we unwrapped it, this length going across is this length around, it's the circumference. So the circumference, well, to know the circumference, we know the circumference is 2 pi times the radius. Well, what is the radius? Well, this guy right here is out an arbitrary length of x. Okay, we don't know what x is, but it's out some x value. However, this x value only covers this distance. Let me do it in yellow here. It only covers this distance right here, we still have this whole distance here for the radius. So it's like the x value covers this, but then we got this chunk right here that we've got to figure out. Well, that chunk is a length of positive 1/2, right? If you ask me how far this is from here to here, you would tell me that it's 1/2 because this is over here at negative 1/2. So the circumference, the radius, is 1/2 plus whatever the little x value distance is here. So now what I've got is I've got the full radius, this guy right up top here. Now what is the height? Well, the height is the difference between these two lines. So the height is 1 minus the square root of x. Now we're set to go. So what we're going to do is we're going to take these three things and multiply them together. And that's our volume. But we want to add up all of the little cylinders. And there's a bunch of them. So we're going to add up all of these cylinders. And now since we're adding up a bunch of them, an infinite amount of them, right? This delta x becomes super small. We call it dx. Now the x varies. X varies from 0 down to here where these guys intersect, and this line intersects at positive 1. So we're going to vary from 0 to 1. And the rest of it is just computation. Okay, that was the hard part. Okay, the rest of it is trying to solve this guy. So let's pull the 2 pi out. Now let's multiply together these two guys. So I'll write them out here. 1 minus the square root of x times 1/2 plus x dx. So we need to FOIL this guy on the inside. So let's go ahead and do that. So that'll be equal to the following. 1 times 1/2 is 1/2. 1 times x is x. Negative square root of x times 1/2 is negative 1/2 square root of x. And then negative square root of x times x. So square root of x times x is x to the 1/2 times x to the 2/2, which is x to the 3/2. So this will be minus x to the 3/2 dx. Now we're going to do these each individually. Okay, so this will be 2 pi from 0 to 1 of, now wait, hang on. I don't want to write that like that. I want to write it like this. Now the antiderivative of 1/2 is just 1/2 x. The antiderivative of x is x squared over 2. The antiderivative of square root of x, okay, is, remember, it's x to the 1/2, that's square root of x. So this is going to be x to the 3/2 over 3/2, which is 2x to the 3/2 over 3, multiplied by 1/2, by negative 1/2. So the half and the 2 are going to cancel. So we'll just get x to the 3/2 over 3. And then this guy is going to be minus 2 times x to the 5/2 over 5. Think about that one. And this is evaluated between 0 and 1. Well, when I plug in 0, everything's gone. So the only thing I have to worry about is plugging in 1. So this would be 2 pi times 1/2 times 1 is 1/2. 1 squared over 2 is still 1/2. Okay. Minus 1 to the 3/2 is still 1. So over 3 is 1/3. And same thing here. I get 2/5. So this is 2 pi. This is 1 minus 1/3 minus 2/5. So that's 2 pi. This is going to be over 15. So 15 over 15 minus 5 over 15 minus 6 over 15. So this will be 2 pi times 4/15, which will give me 8 pi over 15. Okay, So again, this is just kind of computational here. The setup is the hard part here, coming up with this guy. Okay. So good luck on those problems, and if you got any questions, send me an email.